In November 2023, a single vote brought the most powerful AI company on Earth to the brink of collapse. The CEO of OpenAI, the man behind ChatGPT, was suddenly fired by his own board. Investors were stunned, employees revolted. The technology industry descended into chaos. But the most shocking detail wasn't that the CEO had been removed. It was who helped remove him. The decisive vote came from one of OpenAI's own founders, one of the people who had spent nearly a decade building the company from nothing, a scientist whose ideas helped create the modern AI revolution itself. And then, just days later, he publicly said he regretted what he had done. How does someone spend years building a machine powerful enough to change civilization, only to become one of the people most afraid of where it is heading? To answer that question, we need to go back long before ChatGPT, long before OpenAI, and long before artificial intelligence became the most important technology on Earth. This is the story of Ilya Sutskever, the man who taught machines to think, and then wondered if they should. Ilya Sutskever was born in 1986 in Nizhny Novgorod, then called Gorky, a closed city deep inside the Soviet Union. It was a city that appeared on no public maps because it hosted classified military research. His family was Jewish, educated, and restless. In 1991, when Sutskever was 5 years old, they emigrated to Israel, settling in Jerusalem. 10 years later, the family moved again, this time to Canada. 3 countries before the age of 16, 3 languages, 3 educational systems. And through all of it, one constant: an obsession with how intelligence worked. At the University of Toronto, Sutskever enrolled as a third-year undergraduate after just 1 month of high school, an institution that looked at his record and placed him 2 years ahead of his peers. He earned a Bachelor of Science in Mathematics in 2005. He stayed for a Master's in Computer Science in 2007. And then, crucially, he stayed again for a PhD, not because of the credential, but because of a single professor. That professor was Geoffrey Hinton. Hinton was, at that time, regarded by most of mainstream computer science as a stubborn eccentric. He believed that artificial neural networks, systems loosely modeled on the biological structure of the human brain, would eventually outperform every other approach to machine intelligence. The majority of the field disagreed, loudly. Neural networks had been largely dismissed since the 1970s as computationally expensive and theoretically limited. Hinton had spent decades arguing the opposite. Almost no one listened. Sutskever listened. Hinton gave his new student a research project: improve a specific dimensionality reduction algorithm called stochastic neighbor embedding. Sutskever worked on it and did well. More important than the result was what happened in his mind during the process. He became convinced, as Hinton was, that the key to intelligence was not programming rules into machines. It was giving machines enough data, enough computational power, and the right architecture to discover the rules themselves. That conviction would take 12 more years to prove to the world. By 2010, Sutskever was a PhD student at the intersection of 2 fields most of his contemporaries considered dead ends: deep neural networks and large-scale computation. The rest of the scientific community was busy with support vector machines, decision trees, and methods that were computationally cheap and theoretically tractable. Sutskever and his colleagues were working on something that required vastly more computing power than anyone had tried to apply to perception tasks, and something was starting to move. The storm was not yet visible, but the conditions for it were perfect. In 2012, a graduate student named Alex Krzyzewski built a neural network in his bedroom. He ran it on 2 consumer-grade NVIDIA graphics cards, the kind sold for playing video games, connected inside a single computer that sat in his parents' house. His PhD advisor was Jeffrey Hinton. His collaborator was Ilya Sutskever. The 3 of them entered that system into the ImageNet Large-Scale Visual Recognition Challenge, a global competition in which algorithms were tasked with correctly classifying 1.3 million photographs into 1,000 categories. At the time, the best systems in the world achieved a top 5 error rate, meaning the correct label was not in their top 5 guesses, of approximately 26%. Their system, which would later be named AlexNet, achieved a top 5 error rate of 15.3%. That was not an improvement. That was a rupture. To understand why this number was so disorienting to the field, consider what it means for an algorithm to be 10.8 percentage points better than everything else on Earth at a task. In machine learning, improving on the state-of-the-art by even 1 or 2 percentage points is considered a meaningful contribution. A margin of nearly 11 points doesn't happen through incremental refinement. It happens when an entirely different kind of approach is correct, and everyone else's approach is wrong. The machine learning community spent the following year trying to understand what had happened. The answer was both simple and radical. AlexNet used a deep convolutional neural network, a system with multiple stacked layers, each one learning increasingly abstract features from the raw pixels of an image. The first layer learned to detect edges. The next learned shapes. Subsequent layers learned object parts. The final layers learned to combine all of that into a classification. The network had 60 million parameters, adjustable numerical weights, all of which were optimized automatically by exposing the system to millions of labeled images. Sutskever's specific contribution to the project was his conviction that scaling would work, that more layers, more parameters, and more data would produce qualitatively better results, not just marginally better ones. This conviction, which seemed extravagant at the time, is now the foundational principle of the entire modern AI industry. Hinton later summarized the team's respective contributions with characteristic dry wit. He said, "Ilya thought we should do it, Alex made it work, and I got the Nobel Prize." Hinton did, in fact, receive the Nobel Prize in Physics in 2024, jointly with John Hopfield, for foundational discoveries enabling machine learning with artificial neural networks. After ImageNet, the 3 formed a company called DNN Research and sold it to Google in 2013. Sutskever joined Google Brain. At Google, he co-authored the 2014 paper that introduced sequence-to-sequence learning with neural networks, a framework in which one recurrent network encodes an input sequence into a compressed representation, and a second decodes that representation into an output sequence. In plain terms, a machine could now learn to translate a sentence in French into English, not by following a dictionary of rules, but by learning the relationship between the 2 languages from millions of examples alone. The paper has since been cited more than 27,000 times. It is the direct ancestor of every modern large language model. But Google, despite its resources, was not where Sutskever intended to stay. He had a different idea about where this was all headed and what needed to be done about it. In December 2015, Sutskever left Google to co-found OpenAI, alongside Sam Altman, Elon Musk, Greg Brockman, and others. The organization was structured as a nonprofit with a specific stated mission: ensure that artificial general intelligence, AI that can perform any intellectual task a human can, benefits all of humanity rather than a narrow set of interests. Sutskever became Chief Scientist. He was 30 years old. Over the next 9 years, Sutskever was the intellectual engine of OpenAI's research. He shaped the GPT series of models, generative pre-trained transformers, championing the scaling approach, the argument that training ever larger models on ever larger datasets with ever more computation would produce systems with qualitatively new and emergent capabilities. When OpenAI released GPT-3 in 2020, and when ChatGPT launched in November 2022 and acquired 1 million users in 5 days, Sutskever's foundational research choices were at the center of both. In 2022, he was elected a Fellow of the Royal Society, one of the oldest and most selective scientific honors in the world, established in 1660. In 2022, 2023, and 2024, he won the NeurIPS Test of Time Award, awarded by the Neural Information Processing Systems Conference, for papers that significantly shaped the AI field over a decade or more. But Sutskever's relationship with OpenAI had begun to fracture. He became the primary leader of OpenAI's Superalignment initiative in 2023, a research program aimed at ensuring that future superintelligent systems could be controlled and directed by humans, rather than operating against human intentions. He publicly wrote that superintelligence was not a distant hypothetical, but a plausible development within the current decade, requiring urgent preparation. Behind this work was a deeper unease. Sutskever had grown skeptical of the direction in which CEO Sam Altman was steering the organization, the speed of commercial deployment, the fundraising from foreign governments, the widening gap between OpenAI's stated safety mission and its operational decisions. In November 2023, Sutskever joined the OpenAI board in voting to remove Altman from the company. He informed Altman of the decision personally. The consequences were immediate and severe. Over 700 OpenAI employees signed a letter threatening to resign if Altman was not reinstated. Microsoft, which had invested $13 billion in OpenAI, made clear its support for Altman. Within 5 days, Altman returned as CEO. Sutskever stepped down from the board. Days after voting to fire Altman, he posted a public statement. "I deeply regret my participation in the board's actions." That sentence, published by one of the most accomplished machine learning researchers alive, raised a question that neither the company nor its critics have fully answered. What did Sutskever know, and what did he believe he was preventing? In May 2024, Sutskever announced his departure from OpenAI. He described his next project as very personally meaningful, without further detail. Hours later, Jan Leike, the other leader of the Superalignment project, also resigned, stating publicly that safety culture and safety processes had been eroded inside OpenAI. In June 2024, Sutskever co-founded Safe Superintelligence, Inc., alongside Daniel Gross and Daniel Levy. Its stated mission was singular: build safe superintelligence. Not a product, not an assistant, not a revenue stream. Within months, the company raised $1 billion from Andreessen Horowitz, Sequoia Capital, DST Global, and SV Angel. In June 2025, Meta Platforms made an acquisition offer. SSI rejected it. Shortly after, Sutskever assumed the role of CEO. In an October 2024 interview following his Nobel Prize, Geoffrey Hinton spoke about the November 2023 events at OpenAI and expressed support for Sutskever's concern about AI safety, saying he shared those concerns about the pace and direction of AI development. What Sutskever is attempting at SSI is not straightforwardly quantifiable. He is not trying to build a faster chatbot or a better image generator. He is trying to construct a system that exceeds human cognitive capability across every domain, and to do so in a way that does not result in catastrophe. In 1991, a 5-year-old boy left a city that did not appear on public maps. 34 years later, the systems he helped design are being used to read maps, write them, and argue about where the road ahead leads. He has not stopped moving.